In this video, I'll cover how to use Trifacta to prepare data for Amazon Personalize. So let's begin by looking at what is Amazon Personalize. Amazon Personalize is a machine learning service that greatly simplifies the process of building robust recommender systems. Amazon has taken the vast experience it has gained from building such systems and made it accessible and simple to use for everyone. You basically provide some historical data to the system representing user activity patterns and product attributes. Based on this information, Amazon Personalize will automatically train a machine learning model that is capable of producing high-quality recommendations that will result in greater user engagement and satisfaction. Amazon Personalize can work with three types of historical datasets. You can provide user data that includes various attributes of your users, such as age, gender, and loyalty membership. You also provide item data, which consists of products or services being offered and their attributes. Thirdly, you can provide data about the interactions between users and items, which serves to inform future recommendations. In this demo, we will prepare movie lens movie and ratings information and enrich it with IMDb. Our goal for data preparation is to produce clean data sets and schema definitions in the format expected by Amazon Personalize. This screen shows the completed flow in Trifacta. On the left are data sources representing the movie lens and IMDb data that are being read from an Amazon S3 bucket. In the middle are recipes for movies and ratings that define the data transformation steps to produce clean data. And finally, to the right are recipes that produce JSON schema definitions that go with the data files. Amazon Personalize will use this data and schema to train a recommender system to deliver personalized movie recommendations. Now let's look at how to build this flow. We begin by creating a flow and adding datasets to it. You can do so by clicking on Add Datasets on the top right. In this case, we have already added movies.csv, which is stored in this location on Amazon S3. You can quickly see a preview of the data before you begin working with it. I will now edit the recipe attached to the movies dataset, and this brings up a familiar spreadsheet-like view of the data that will let us work through the data preparation steps. Looking at the movie titles, I noticed that some of them have extra quotation marks. I can simply use my mouse to select this and notice that Trifacta offers a suggestion to replace these values and remove the quotes. It also shows a preview of the result in this yellow column. These suggestions are driven by machine learning, and I can pick and customize any one of them and simply add it to my recipe. Now this movie lens data has relatively few attributes for each movie. We want to enrich this data by bringing in additional fields from IMDb. To do this, I select Join from the toolbar and choose Links. This table contains an association between movie lens movie ID and IMDb ID. Notice that Trifacta will automatically suggest the best join key. In this case, it's found 100% match based on movie ID. And I can easily simply select the columns I want. In this case, I want to deselect movie ID and add the IMDb ID and add this to my recipe. We now have the IMDb ID in our dataset. However, there is a small problem. We know that our IMDb dataset has a prefix of TT in front of the ID, which we are lacking. So we need to edit the ID to include the prefix to make the join work. So we select IMDb as the column being edited. And in the formula, we use merge and add the prefix of TT before the IMDb ID itself and add that to the recipe. We can now join to our IMDb dataset. We will perform a left join and we will choose the newly prepared column in order to as the join key. And then we can select the columns we want to keep in the output. So I will pick up the movie ID from the movie lens data, and the rest of the fields I'm going to choose from the IMDb dataset, which include the title type, the primary title, the start year, runtime in minutes, and genres, and add this to my recipe. Notice that we see a bunch of nulls for the new columns. This is because the IMDb dataset is huge and our initial sample did not contain matching records for the IDs displayed here. We can easily fix this by drawing a new sample. I'm going to choose the random sample method and create a sample based on the full dataset. The sample is now ready, so I'll click on the Load Sample button to switch to it. And notice that now these columns are all filled in. I'm going to make some other changes on the genre field. I'm going to replace the delimiters. Instead of a comma, I'm going to edit this and replace it with something else. And instead of a comma, we're going to be putting the pipe symbol in. And the final thing I'll do is rename the movie ID in this movie dataset and call it item ID. This is the format that Amazon Personalize expects the item ID to be in. I can actually rename multiple columns at the same time. So I will use names that match what is expected by Amazon Personalize. So we have column 2 being the user ID, column 3 is the item ID, column 4 is the rating, and column 5 is the timestamp. And add that to my recipe. And we will choose greater than or equal to, so the rating is greater than or equal to 3.6. Our movies and ratings data is now ready. The next step is to generate schema definitions for them. I have pre-created the recipes that generate the schema in the format expected by Amazon Personalize. I will now attach these to the respective datasets. The items schema is attached to the movies dataset, and the interaction schema is attached to the ratings dataset. The flow is now ready. The final step is to define the outputs that we want and run jobs to produce these outputs. Our outputs will be stored in an S3 bucket that is accessible to Amazon Personalize. We will persist the data files as CSV files and the schemas as JSON files. We'll do the same for movies, which are items, as well as ratings, which are the interactions. You can select each output and click on Run Job to actually produce the output. And you would do this for movies, item schema, interaction schema, and ratings. And once that's done, you can come to the jobs panel and review the previously executed jobs. In this case, I'm going to open up the ratings, and you can access a detailed profile of the data that was generated, as well as the location of the output, which in this case was a CSV file on an S3 bucket. You can now access Amazon Personalize from the AWS console and create a dataset group and dataset that point to the S3 bucket and files that were outputted by Trifacta. Based on these datasets, you create solution versions, which are trained models, as well as campaigns, which are deployed applications that you can use to generate recommendations. It consists of an item ID plus up to 6 categorical variables. The item data is accompanied by a JSON schema that describes the names, nature, and data type for each column. The interactions dataset has the data outputted by Trifacta containing the user ID, item ID, and timestamp, as well as the JSON schema definition that describes their respective types. Ultimately, investing in data preparation with Trifacta pays off in the form of better recommendations from Amazon Personalize. You can see from the model metrics that the recommender system delivers higher scores due to enrichment and improved data quality. All of the datasets, flows, and other demo materials are included in a GitHub repository you can access in the description below. I highly encourage you to try it out yourself. Thank you.